Okay, so let's start with, oh, I don't really want orange. This is in your AP Physics unit. This is section 1.5. It is called projectile motion. Or motion in 2 dimensions. Okay, so when we're talking about objects that are in motion, a lot of the time we're talking about things moving in 1 dimension. I just walked across the classroom. I'm moving only in 1 dimension because I have only horizontal movement. But a lot of times we have situations where we're moving both vertically and horizontally, and we need to think about motion as 2 independent pathways. So on your XY axis, if you have let's draw a butterfly. That's something I can do. Does that look like a butterfly from where you're sitting? Yes. Probably not even. Oh, it does? Okay, good. Okay, so horizontal motion would be the butterfly moving in this direction. And so it would be farther along on the x-axis. That makes sense to us. That's what we do when we drive to school. We drive horizontally. But because we have a butterfly, the butterfly can move vertically as well. And so the butterfly in this diagram, in this depiction, is just moving straight up. Neither of these pathways, though, properly describe how a butterfly actually moves, because the butterfly is moving freely. It doesn't have to just move straight up. Like, so have you guys ever seen a 3D printer? Have you ever seen it move? It prints one layer, and then it moves up a little bit and prints another layer, and it moves up a little bit and prints another layer, and that's how it prints the objects. And so in a 3D printer, it can only move vertically or horizontally. It can't do both. But a butterfly, we know, can. And so when you are combining the motion of vertical and horizontal, your path looks something a little bit more like this. So what we have to do when we have projectile motion problems, or anything that's launching or taking off from a location where you're having that combination of vertical and horizontal movement in one swoop, in one fell swoop, you have to look at the motion independently. And so we have to be able to break this up into its horizontal and vertical components, because that's the only thing that we have math equations to deal with. Okay, so what will that look like? It means that we're going to always, when we start our problems, we're always going to have a data table that has 2 independent sides. You're going to have your x values and your y values. The x side is your horizontal motion. The y side is your vertical motion. And so what kind of variables will you have? Well, you'll have the distance traveled, which we have so far been using as x because we've been talking only about horizontal motion. And so let's write that here in the red. This is your horizontal displacement. You will have the initial velocity in the x direction. You'll also have your final velocity in the x direction, which most of the time we don't know. You'll have acceleration in the x direction, which is really convenient because in projectile motion, we are going to consider that air resistance is negligible. And so if nothing is going to prevent your object from moving horizontally because we're pretending that air resistance doesn't exist, we're going to say that AX equals 0. And that'll be really convenient for math later on. Now we are also going to have all of these variables in the y column as well. So for y, we're going to now have our vertical displacement. Vertical displacement, okay, so if you think about projectile motion, think about a kickoff in football. You kick the ball a certain distance, and it also reaches a certain maximum height. The vertical displacement is your maximum height. I'm not going to write that here because that's not always true. So I'm just going to leave that. It's the vertical displacement. So just like it was before, this is your initial, V naught y is your initial velocity in the y direction. And now this is a really important thing. If your object is launched horizontally, we'll do some examples of this. What would be an example of launching something horizontally? If you had a Nerf gun and you held your hand like exactly like parallel to the ground and you shot your Nerf gun, that would be horizontal launching. If that is true, V naught y equals 0. So a lot of times your problem doesn't tell you that this is true. Your problem does not explicitly say this, because it'll use words like it is launched horizontally. A cannon is fired horizontally. That means that V naught y is 0. You also will have V final y, but again, we often don't know that velocity, and so I'm just going to leave that blank there because in most of your data tables, you'll leave it blank as well. Your acceleration is going to be due to gravity. Sometimes it'll be positive and sometimes it'll be negative. You just have to think about what your situation is. What is your frame of reference? So I'm going to write on here plus or minus 9.8 meters per second squared. You have to choose the plus or the minus though. And then in your kinematics formulas, there's one final variable. Tx is equal to Ty. Why is that true? Because the time it takes for the football to get from one end zone to the other, or from one location on the field to the other, is the same if it's traveling just vertically or if it's traveling just horizontally. So Tx is equal to Ty. This is going to be a strategy for solving these problems. So how do you solve a problem like this? Start out by writing this kind of a data table. Even if you start by just putting, like having all of these things empty, you can fill them in as you go. Almost never will you have anything in the finals. And then look at the column that has more information. Whichever column has more information, probably solve for T, and then you can use that T to solve for anything on the other column. Okay, that doesn't make any sense to you right now because we haven't done any problems like this. So let's do some examples. Do you guys have your books? Does somebody have a book? Grab out your books. Let's do some examples. Let's start with example 6, I think, on page 66 is what I have marked down. Yes? Sure. Leave the door open then. This is page 66. We're going to do example number 6, where it says the height of a kickoff. Okay, let's read our problem. A place kicker kicks a football at an angle of theta equals 40 degrees above the horizontal axis, as figure 3.1 shows, or sorry, 3.10. The initial speed of the ball is V naught equals 22 meters per second. Ignore air resistance and find the maximum height that the ball allows. Okay, now the book is going to show you how to do things there. Ignore that and watch this. Okay, so the first thing I'm going to do is I see that I've got this kind of a graph for the launching of a ball. I know that my angle is 40 degrees. And I'm given a V naught. Was that 20 or 22? 22. Thank you. Okay. So I'm just going to sketch this out on my work because it's going to help me to visualize what's going on. I know that none of you are as bad at spaces as I am, but I think having something to visualize is a good thing. So drawing a picture in physics is a good idea. When I see motion like this looks like the butterfly, so that means I need this. This is going to help me get started. Okay, so I'm just going to write down all the possible variables I could get. I know that tx equals ty, and I'm just going to put that down in the middle to help me know that if I get that value, it applies to both columns. Okay, so get that. These problems are a little tedious because you have to do this. Can you get away with not doing this? Not well. You'll drive yourself nuts if you don't do this. So just do it. It might be one of those things where it makes your hand hurt and maybe you'll get sweaty. I don't know. Did I tell you about this? Jake had to do electron configurations the other day in class, and he wanted to finish the assignment before the bell rang, and so he was like furiously writing all these electron configurations out. Then he like throws it on my desk, and he's like, "Mom, check this. This was horrible. I didn't like anything about this. My hand hurts, and I'm sweating." I'm like, okay. So maybe this will make you get sweaty. I don't know. Okay, so before we go back to the problem, let's fill in the stuff that we know. We know that AX is 0. How do we know that? Well, it did say to ignore air resistance. So in all of these problems, horizontal acceleration is 0. We know that acceleration is plus or minus 9.8 meters per second. And so I'm just going to leave that empty, like that space in between, because I don't know. I don't want to decide yet if it's plus or minus. It asks me the maximum height. That's y. So question mark is y. Does it tell me how far he kicks the thing? It doesn't. I don't think it does it?
No.
How far downfield he kicks. Okay, so we don't have an X, just leave that blank. But we do have some other information. we've got a V naught. But now we're going to have to use a little bit of trigonometry here, because the V naught, if you have a triangle, and this is that 40 degrees from your problem, 22 is the hypotenuse. How do you know? Because it tells you that the speed at which it leaves the foot and is going in this direction, that's 22. So, what can we do? Well, we can find what V naught y is. V naught y is this variable here, this part of the triangle. Oops. So what side is this? Is this the adjacent or the opposite side of the angle?
Opposite.
So we should use sine or cosine? We should use sine. Sine of theta is equal to the adjacent divided by the hypotenuse. Okay, so how do you solve for V naught y? We want to get this by itself, so this 22 has to come over here. Now that we know that this is what it looks like, you don't need to draw your triangle and do this step every time. V naught y, if it is the opposite side, is always equal to V naught times the sine of your angle. Okay, so make sure that your calculator is in degree mode. We don't ever use radians in this class. So if you are in pre-calc or calc right now, you're going to have to change it every single time you go between classes. So 22 times the sine of 40, I got 14.1. Is that what you got as well? That goes in this space in your data table. Okay, so do we have enough information to calculate y?
Degrees. It's always in degrees.
It has to be in
You're in
degrees.
trig.
You're not going to use radians at all in this class. Okay. We don't have any really useful x data. I mean, we could find V naught x. We could use the cosine of our angle, but we don't really have that. What we do have, though, is this, oh, sorry. I keep doing that. What we do have is this value. What is the value of V final y? Say that again? It is 0. Let's talk about why that's true. If we're looking for y is really, dang nabbit, the height at the zenith, the apex, the top of its path. And so that's the point at which your y velocity is equal to 0. In the same way that when we throw something up, dang it, like vertically, at the top of its motion, when it stops, that velocity is equal to 0 because it's the point at which it's changing directions. Here, your velocity in the y direction is going to slow down until you get to the top. And then it'll speed up again. So crying out loud, does that mean that our acceleration is positive or negative? Okay, so look at these two things. V initial is 14 and V final is 0. Did it speed up or slow down?
Slow down.
It slows down, it's negative. So just remember that whenever your object is going up into the air, acceleration due to gravity is always trying to pull it back down to Earth. So it's trying to slow it down. Okay, there is a formula that uses all of this information. It's the third one in the list on your formula sheet, I think. So that one looks like this. But now it has the X in the formula, which is not really what we want. But this is a really important thing. Any of the formulas work for either the X or the Y direction. They just can't work for both. So this, like you can't use Y and X interchangeably. This is true. And so is this. They are the same formula, just with your variables first in the X column and second from the Y column. What you cannot do, so this is good, this is good. What you cannot do is intermingle. That's very bad. So don't be doing that. Stay in one column of your data table. Okay, but this is the one we want to use. We are looking for Y though, so stay with me. I'm going to solve for Y. Now, if something is 0, I'm going to go back to my data table. My data table tells me that B final is 0. So, when I'm doing my algebra, this is going to go away. And so I'm left with 0 equals V naught Y squared plus 2AY times Y. I need to get Y on its own. So I'm going to subtract this whole term from both sides. And now I will have negative 2AY Y equals V naught Y squared. Why do I have the Y here? Why are there two Y's? Because that little y tells me that I have acceleration in the vertical direction. I'm solving for y, so now I'm going to divide negative 2a little y on both sides. And so my formula should look like this. Now that I've done this, I can put my numbers into my formula and get an answer. 14.1 is my velocity. My acceleration is negative 9.8. So here's where you can double check if you got the right answer when you chose the plus or the minus for the acceleration. It's not always wrong to get a negative distance, but it's a really good practice when you're solving these physics problems to, when you get an answer, think to yourself, is that reasonable? Because sometimes it is reasonable. Like if your object dropped below what you are calling like 0 as your frame of reference, then a negative distance is possible. All right, so I'm going to square that and divide by 2 times 9.8, and I got 10.2. Does that seem logical? Well, 10 meters is almost like 10 yards. 10 yards is almost like 30 feet. Is it reasonable to think that an NFL kicker or a place kicker, I guess it didn't say if he's in the NFL, for him to kick it 30 feet in the air? Do you think that's reasonable? That seems reasonable. That seems reasonable. So I think that's the answer. All right, let's do another example. Let's do number 7 on the next page, on page 67. Okay. For the motion illustrated in figure 3.10, ignore air resistance and use the data from example 6 to determine the time of flight between kickoff and landing. Okay, so what we're really going to do is use what we had before. I made a mess of the board, so I'm just going to quickly recopy the things that I know to be true. And you don't have to if you don't want to. I know that it'll be nonsensical. Now my time is new question mark, but I do have some new data. I've got that 10.2 meters that I just calculated. My Vy initial is the 14.1. I don't know what V final is, but I do know that AY is equal to 9.8, and again, I don't want to decide that. Okay, so I'm going to draw my picture. This is the point that we calculated. This is that y equals 10.2. Okay, so we've got a lot of data there. Let's see if one of our formulas from our blue formula sheet has time in it. What we don't have is that final velocity. And so, oh wait, well, we do. We do. If we calculate, if we say that we're only looking at this path here, from the start, from kickoff, to the part where it's in the middle, we can find time using all of this data. But then what will we need to do with this value to get time from the beginning to the end? Okay, so come back. We're starting here. We know that the y value of the middle of the path is 10.2 meters. And we also know that at this point, velocity is 0. So we can use all of this data to calculate t. The question, though, asks, what is t for the entire motion? So what will we need to do with this value to get t for the whole thing?
Multiply by 2.
Multiply it by 2, yes.
That will do.
That'll work. All right, so let's use a formula that makes sense to us. Did that make sense, or did I confuse you?
Yeah, because it's horizontal.
All right, which formula do you want to use? David?
I have a quick question.
Yeah.
So gravity, like, since it's going, wouldn't it be going down quicker than it like went up? So wouldn't the times be different? That's not how it works.
No, because gravity is always the same.
Okay.
The pull of the Earth on you is constant.
Okay.
It always, because the Earth always has its same mass, and which is incredibly greater than the mass that you have. So even if you gained 500 pounds, gravity would still affect you in the exact same way,
Okay.
because your mass is almost irrelevant.
Alright.
100.
We use the first one.
Let me think about that for a minute. Could you use the first one? You could, but I think the second one is more better. I mean, the first one is less complicated, but the second one it gives you a better description of what your motion actually is. And that's why and so this is one of those things about physics that I hate. Like, there's not always a formula to use. Like, how do you know which one to use? And the answer is yes. It's like, you choose what you want. So if you want to choose that one, you can, but I think that the second one is usually, the second formula is just the one that makes more sense. Now, unfortunately, that means that we're going to have some situations here because we've got t in two different places. Now, okay, so this is what, I would maybe write this next to this formula on my blue sheet, because this is so overcomplicated. What is on here is more complicated than it needs to be. We're never going to choose an x other than x equals 0, because we have the ability to choose our frame of reference. So why would we make things more complicated for ourselves? That's ridiculous. And then the same thing with x minus x0 at the end of that third formula as well. It's nonsense. Okay, so copy this down. But now, because we're using the y stuff, we maybe want to write it like this. It doesn't really matter, it's the same thing. So as long as you can keep track mentally of what's going on, it's fine. Okay, so I see already that I've got a t and a t squared. That means that I'm going to need to use the quad form. So what I'm going to do, thank you so much. I'm recording this lecture for you. So take your time and relax yourself, because you'll watch this later if you want. Okay, so let's do some algebra first. Let's just do, I'm going to do a little bit of rearranging, and that's it. The reason I did this was because I want there to be, like, it's always ax squared plus bx plus c. That's how you set up your quadratic formula. And so now all I need to do, because I'm going to use my calculator's program, we did that a while back, a is equal to 1/2 times whatever you have from your data table. But is that 1/2 of positive 9.8 or negative 9.8?
Negative.
It has to be negative because you're in the first half of the motion. Remember, when you launch something into the air, acceleration is always negative. Okay, b is v naught, but in the y direction, and we calculated that. That's that 14.1 again. And c equals 0. So let's get our calculators out. And you don't even have to figure out what 1/2 times negative 9.8 is. You can do that right in your calculator. So just tell it, when it says a equals question mark, just put a parentheses around 0.5 times negative 9.8. Make your calculator do the work. B is 14.1 and C is 0. Oh, and if you don't, I gotta edit my, I'm a dummy. Oh, I don't know why mine didn't, did anybody get an answer?
2.8.
2.8. That's your time, so that seconds is your unit. But remember, we needed to multiply it by 2. Because that was for this part of the motion only. So 2.8 times 2 is 5.6. That's what we call the hang time of a kick. The longer your hang time, the longer that time is, if you're doing a kickoff, well, I guess not anymore, because in the NFL now, in a kickoff, nobody starts running until the person starts running the returner starts running, which is stupid and ridiculous. I hate it. But okay, so pretend that you're doing a punt, I guess. The longer that time, the better, because you give your defense a chance to run down the field. So I think 5.6 is pretty good. Okay, if you're having a hard time, don't worry. It'll get easier the more you do. let's do example 8. Actually, I'm just going to leave this up here because in example 8, it's asking us for the range. The range is your x distance. So now we're going to use information and solve for x. Okay, so the reason that the book takes us through these examples is because it shows us how to do one part, then the next part, and then the third part. So you could have gotten all of this information, and your question would have, there might have only been one question. The question might have been, what is the range? You had enough information to answer to get that answer, but you had to answer all these other questions before you could do that. So now t doesn't equal question mark anymore. For the full distance, it's the 5.6 seconds. What's v naught x? Well, let's go back up to here to my little triangle. Someplace I have it. Here it is. If this line here is v naught y, this red line here is v naught x. If v naught y was equal to v naught times sine of theta, v naught x is equal to v naught times the
Cosine.
good. It's always usually one or the other. Okay, so I'm going to take that information down with me over here. So I could have also written the actual numerical answer, which would be 22 times the cosine of 40, I think it was. 16.8 meters per second. And now I have a lot of useful information. It's a lot more fun to find things from the x column because you've got a 0. So let me use this same formula, v naught t plus 1/2 at squared. The 1/2 at squared goes away because a is 0, and anything times 0 is going to be a 0. So that means x is just simply equal to v naught times the time. We know v naught, we just calculated at 16.8. And we know the time from doing the last problem, the 5.6. And so if you're traveling at that velocity for 5.6 seconds, we're not speeding up or slowing down because we're thinking about it only traveling in the horizontal direction. And if wind resistance isn't a thing, 94.1 meters is what I got for an answer. Did you get that too? Is that good for a place kick? I mean, because you don't start at the end zone on a place kick. I mean, a 94-meter kick, that's like 97 yards. That would be way out the back of the end zone. So that's how we can calculate that. Okay, so that's the last example I'm going to do for you. I'm going to give you your homeworks. There's 2 of them because you're going to have the whole rest of the time today to work on the first one. And then I got to have something for you to do next class. So homework number 4, they're both due next class. On pages 80 to 81, actually I'm going to write this on the whiteboard. Hopefully you don't need this anymore, Hunter, but if you do, let me know. Alright, homework number 4 is pages 80 to 81, and I would like numbers 16 through 20. Homework number 5 is page 81. 26 through 29. So it's 8 problems total, 2 separate assignments. I will have an answer key on Friday for both of these problem sets. In order to see the answer key, though, you're going to need to show my sub that you have worked on the problem. So you're not just looking at the solution. You're not just using me as your chat GPT before you've made an attempt.